Welcome to clickmyproject.com. Let us discuss about the secure transmission in cooperative relaying networks with multiple antennas. Let us discuss about the abstract of the product. So when we investigate the secrecy performance of dual hop amplifier and forward multi-antenna relaying systems over relay fading channels, considering the narrow link between the source and destination. So in order to exploit the available direct link and multiple antennas for security improvement, different linear processing schemes at the relay and different diversity combination technique at the destination are proposed. So that are namely zero forcing maximal ratio combining, so that is a ZF MRC, and then zero forcing selection combining, so that is a ZF NSC, and the maximal ratio transmission and MRC, so that is a MRT and MRC. So MRC means the maximal ratio combining, and then MRT and SC. So MRT means maximal ratio transmission, and SC is a selection combining. For all the schemes, we present new closed form approximation for the security outage probability. So moreover, we investigate a benchmark scheme, so that is a cooperative jamming of ZF, so that is a zero forcing, where the security outage probabilities is obtained in exact closed form. So in addition to, we present the asymptotic security outage expression for all the proposed schemes in high signal to noise ratios, that is SNR, in order to characterize a key design parameters, so such as diversity order and security array gain. So the outcome of this paper can be summarized as follows. So the MRT and MRC and MRT and SC achieve the full diversity of the M+1, and then ZF MRC and ZF SC achieve a diversity order of M, while the CJ, so that is a cooperative jamming and zero forcing, only achieves a unit diversity order, while M is the number of antennas and the relay. So the ZF and MRC outperformance the corresponding MRT and M. So that is in the low SNR region, while becomes inferior to the corresponding MRT and MRC. So that is a maximal ratio transmission and maximal ratio combining. So in the high SNR, and all the proposed schemes tend to outperform for the CG and ZF. So that is a cooperative jamming and zero forcing with moderate number of antennas, and linear processing schemes with MRC attain the better performance than the CC. So the SC is a selection combining. So all the proposed schemes tend to outperform of the CJ ZI with moderate number of antennas, and linear processing scheme with the MRC attaining the performance than the selection combining of the scheme. Let us discuss about the flow diagram of the product. So this is the overall flow diagram. First of all, the system model. So in this block, we consider a dual hop multiple antenna AF relaying. So that is a AF means amplifier and forward relaying network. So where both source and destination and eavesdrops are equipped with a single antenna, while the relay is equipped with the M antennas. So we consider this is the system model of the process, and then the system model is going to the source, relay or with M antenna. So in the relay is equipped with M antennas, and source and destination is with the single antennas. So this is the system model of the process, and then the system model is combined to the two linear iterative approach. So that is a zero forcing. One is a zero forcing and another one is a maximal ratio transmission. So that is a MRT. Furthermore, since the both destination and eavesdrop receiver to independent version of the source message, diversity combining schemes can be applied. So in this paper, we consider both MRC and selection combining at the destination, while for the eavesdrops, we only consider the MRC scheme. Therefore, depending upon the linear processing scheme adapted the relay and destination, four secure transmission schemes is investigated. So this is a secure performance analysis. So these are the four scheme of transmission scheme. One is a ZF MRC, ZF SC, MRT MRC, and MRT SC. And then the security outage probability. So in addition, we adding the CJ ZF scheme. So that is a cooperative jamming with ZF schemes. Also analyzes the role relay model is jamming signal radio to quality of eavesdrop channels. So the main contribution of this paper to summarize. In ZF MRC, ZF SC, we present novel closed form, lower and upper bounds for the security outage probability and the probability of non-zero security capacity respectively. So as well, the simple high SNR security outage analysis. Furthermore, we show that ZF MRC and ZF SC achieve the same diversity order of M, where M is the number of antennas at the relay side. So next one is the MRT and MRC and MRT and SC closed form approximation of the security outage probability and the probability of non-zero security capacity or provider respectively. In addition, we characterize the high SNR security outage probability, and so that MRT and MRC and MRT and SC achieve the full diversity order of the M+1. So in the CR-ZF scheme, new exact closed form expression on the security outage probability and the probability of non-zero secure capacity are derived. Moreover, we characterize the high SNR security outage behavior of CJ and ZF scheme, which reveals that it achieves security diversity of order 1. So the analytical results suggest that the ZF MRC and MRT and MRC schemes always achieve the better performance than the corresponding ZF and MRC scheme. So in addition to the ZF MRC scheme outperforms the corresponding MRT and MRC scheme in the low SNR region, while in the high SNR region the MRT and MRC scheme attains a better security performance than the corresponding ZF MRC scheme. So finally, the performance analysis, we get the security of outage probability of the scheme. The result demonstrates that all the proposed scheme tends to outperformance of CJ and ZF scheme. So that is a cooperative jamming and zero forcing tend to outperform with moderate number of antennas. So especially when the quality of each tap channel is met. Moreover, increasing the number of antennas at the relay provides marginal performance gains for the CJ and ZF scheme, while it is significantly enhances the security performance of the proposed diversity scheme. So in this paper, finally we get the analysis of outage probability to all those the four schemes. Finally get the outage probability of the security of the performance. So these are the overall system model of this process. Yeah, let us discuss about the running procedure for the product. So click the main file and then run. So all the figures related to our flow diagram. Yeah, in this figure the system model for the relaying scheme. So this is source and this is a destination. So in the source to destination, the communication between the source and destination is a direct link, and then the source to relay, so there is a with the m number of multiple antennas, and the eavesdrop, so the red line is indicated in the source to eavesdrops and the relay to eavesdrops, for source to relay and relay to destination. So this is the communication of the relay to destination scheme. So this is a direct link of the source to destination. So this is the system model for the relaying scheme of the process. Yeah, in this figure the secure outage probability of the ZF MRC and ZF SC relaying systems with different relay antenna number of m. So the analytical results and highest approximation and the ZF SC scheme and the ZF MRC scheme. So in the x-axis we consider gamma 1 of dB and the y-axis is secure outage probability. So we consider the analytical result and with the highest SNR approximation. So the ZF is a zero forcing and the SC is a selection combination. So the ZF in the zero forcing algorithm to using the MRC and the value of maximum ratio of the combining, we calculating the analytical result with high SNR scheme of the process. So they give security outage probability of the ZF MRC and the ZF SC relaying system with different relay antenna number of the scheme. So the n number of antenna is using in the proposed scheme. So the gamma and 1 of dB we consider the EB by NR, so that is a SNR, and then y-axis is consider the outage probability of the process. In this figure, consider similarly the same process. So security outage probability of the ZF MRC and ZF SC and MRT MRC and then MRT SC schemes with MS is equal to 3. So number of antennas, we getting the results of MS is equal to 3, and the analytical results and high SNR approximation and the ZF SC scheme and the MRC. So we calculating in the x-axis the gamma of 1 of dB and then the y-axis security of the outage probability of the process. Yeah, in this figure, security outage comparison of the proposed scheme that and the ZF scheme with gamma 1 is equal to 20 dB and gamma 3 is equal to 5 dB and different gamma 4 are selected. So the schemes are four considered scheme, and only we added the cooperative jamming of his zero forcing algorithm. So there is a blue indicating the blue, the security the outage probability, and MS the different scheme of multiple antennas 0 to 25 of the antennas. So the securities of the outage probability comparison, the proposed scheme with the cooperative jamming of the Z forcing algorithm. So these are the overall running procedure for the product. Thank you for listening this video.